Unlike addition and subtraction, multiplication of surds can be done on both like and unlike surds. Essentially, surds should have same order in order to perform multiplication. In this video, I will explain how to multiply surds when they have different orders. Before that, let me explain multiplication of surds with same orders. Procedure of multiplication of surds having same order is very simple. First step is to reduce them into simplest form and then apply distributive law and do the multiplication of radicands. Consider a simple example. Multiply square root of 5 into square root of 3. These surds are already in their simplest form. Now multiply the radicands. It is square root of 5 into 3. So answer to this question is square root of 15. Now let's learn multiplication of surds when their orders are different. You have studied in your previous classes that surds can be expressed in index form. First step is to express the surds in the index form. Second step is to find the LCM of the different orders of the surds. And the third step is to multiply and divide each index by the LCM and simplify. Fourth step is to rewrite the index form again into surd form. Fifth and last step is to use the exponent rule and do the multiplication. Let me explain this with an example so that you understand it better. Multiply cube root of 2 and fourth root of 3. If you notice, these two surds have different orders. The first surd has order 3 and the second surd has order 4. The first step is to express these surds in their index form. Cube root of 2 is 2 to the power 1 by 3 and fourth root of 3 is 3 to the power 1 by 4. Now calculate the LCM of 3 and 4. LCM of 3 and 4 is 12. Second step is to multiply and divide indexes by 12. It is 2 to the power 1 by 3 into 12 by 12 and 3 to the power 1 by 4 into 12 by 12. Simplify these index forms. 1 by 3 into 12 by 12 is nothing but 4 by 12. And 1 by 4 into 12 by 12 is 3 by 12. So it is 2 to the power 4 by 12 into 3 to the power 3 by 12. This can also be written as 2 to the power 4 into 1 by 12 and 3 to the power 3 into 1 by 12. Next step is to writing these index form again into surds. It is 12th root of 2 to the power 4 into 12th root of 3 to the power 3. So it is 12th root of 2 to the power 4 into 3 to the power 3. I am using fourth law of exponents, which states nth root of a into nth root of b is nothing but nth root of a into b. 12th root of 2 to the power 4 into 3 to the power 3 is nothing but 12th root of 16 into 27. 2 to the power 4 is 16 and 3 to the power 3 is 27. Product of 16 and 27 is 432. So answer to this question is 12th root of 432. Let's do the multiplication of binomial surds. Multiply 3 into square root of 18 plus 2 into square root of 12 by square root of 50 minus square root of 27. First step is to reduce the surds into their simplest form. Take the first surd, 3 into square root of 18. 18 can be factorized into 9 and 2. Hence, it is 3 into square root of 9 into 2. 9 is a perfect square of 3. Hence, it is 3 into 3 square root of 2. So, the simplest form of 3 into square root of 18 is 9 into square root of 2. Similarly, try to find the simplest form of other three surds as well. 2 into square root of 12. 12 can be factorized as 4 into 3. 4 is a perfect square of 2. Hence, 2 into square root of 12 is equal to 2 into square root of 4 into 3. It is 4 into square root of 3. Let's find the simplest form of square root of 50. 50 can be expressed as 25 into 2. 25 is the perfect square of 5. Hence, it is 5 into square root of 2. And square root of 27 can be expressed as square root of 9 into 3. It is 3 into square root of 3. We have found simplest forms of all these surds. It is in the bracket 9 into square root of 2 plus 4 into square root of 3 bracket complete. And the bracket 5 into square root of 2 minus 3 into square root of 3 bracket complete. Now do the multiplication. Multiply 9 into square root of 2 with 5 into square root of 2 minus 3 into square root of 3. And multiply 4 into square root of 3 with 5 into square root of 2 minus 3 into square root of 3. Multiplication of 9 into square root of 2 and 5 into square root of 2 is nothing but 45 into 2. Because 9 into 5 is 45, square root of 2 into square root of 2 is nothing but 2. And multiplication of 9 into square root of 2 minus 3 into square root of 3 is 27 into square root of 6. Because multiplication of coefficients 9 and 3 is 27 and multiplication of square root of 2 and square root of 3 gives square root of 6. Similarly, multiplication of 4 into square root of 3 with 5 into square root of 2 is 20 into square root of 6. And multiplication of 4 into square root of 3 minus 3 into square root of 3 is 12 into 3. The multiplication of coefficients of 4 and 3 is 12 and multiplication of square root of 3 and square root of 3 is 3. Now try to simplify this. 45 into 2 is 90. Minus 27 into square root of 6 plus 20 times of square root of 6 is minus 7 times of square root of 6. And 12 into 3 is minus 36. Hence, it is 90 minus 7 times of square root of 6 minus 36. 90 minus 36 is 54. It is 54 minus 7 times of square root of 6. Answer to this question or the multiplication of these two terms is 54 minus 7 times the square root of 6.